on a trig, things to do with trigonometry, ask you on the non-calculator paper or even on the calculator paper for exact values of trig identities. So, and there are a few different places where you can find these, but I'm going to show you how to derive them because you need them for both A-level and for higher GCSE. And I'm just going to draw a little table. I love a table. I mean, doesn't everybody? So in this table, we've got 0, 30, 45, 60, 90. Okay, and you can find various other things based on this. And we're going to do sine, cos, and tan. And I'm going to now draw a little diagram. Now you can do this based on your... I'm going to be doing various diagrams. You can do this based on your calculator, but it's a good idea to sort of memorize these. So these are sine, cos, oh my goodness, that's -1. Gosh, I'm silly. -1, 0, and tan. There we go. Right, now sine, we're going to mark up 180, 360, and obviously these are 90 and 270. So 90, 180, 270, and 360. And finally 90, 180, 270, and 360. Okay, I'm just going to change colour. So if you put sin0 into your calculator, you'll get 0. If you put sin90, you get 1. If you put sin 180, you get 0. 270, you get -1. And 360, you get 0. So this is what sine looks like. And sine waves are really important. They're like the basics of music and various other things, as are cos waves. Because as you will now notice, they're almost the same. So cos of 1 is, cos of 0 is 1. Cos of 90, which looks like 30, is 0. 180 is -1. 270 is 0. And 360 is 1. So we just draw those in. Ooh, whoops daisy. And tan, now this one's a bit tricky. Tan of 0 is 0. This is the one that I don't automatically know, to be honest. Tan of 0 is 0. And when I'm doing things with A-level, I just convert everything into... Now, tan of 90, this is one of those things that people get wrong quite often. Tan of 90 is math error. So it has... This is called an asymptote. And what happens is it just goes that way. And it doesn't ever quite touch the line. Now, that now means that it comes from there, from down there, and goes through 180. And then it starts going that way, and there's another asymptote at 270. And then it comes from down there and starts going, and 360 goes through 0. Now, this means we can fill in parts of this little table using these graphs. So if we see sine of 0, we know it's 0. Cos of 0 is 1, if you look here. And tan of 0 is 0. Right, now we're going to look at 90. So 90 for sine is 1. 90 for cos is 0. And tan of 90 is, it's an indefinite, it's an error. Okay. Now I can't tell you anything else from there. So what we're going to do now is we're going to draw our little, we're going to draw an equilateral triangle. Well, I'm going to try and draw an equilateral triangle. Now that is not that equal, I don't think, but it's not the end of the world. So as we all know, the interior angles, I'm going to redraw that. I don't love it. Serves you right for doing things freehand, I suppose. But there we go, that's better. The interior angles of an of an equilateral triangle are all 60 because the interior angles of a triangle are 180. An equilateral triangle, it will be 60. So now we're going to change this into two triangles. We're going to make a right angle so we can use right angled trig, or SOHCAHTOA as it's known. And we're going to mark that up as 60. That would be 30, but I'm not going to worry about that just yet. And that's our right angle. Now we're going to do the 60. We're going to do this one here. Okay, we're going to use SOHCAHTOA. And they're going to mark up the sides of the triangle. So that would be opposite. This obviously is hypotenuse because it's opposite the right angle. And this is adjacent. So we know, and now this, we're going to make this 1. Okay, so we're going to make that 1. So that means if that's 1, that means that's half. And that means this one here is going to be, and we're going to use Pythagoras for this, 1 squared minus half squared equals O squared, which would be 1 minus a quarter equals O squared, which equals root 3 over 4, which equals root 3 over 2, because we know the root of 4 is that. So that is root 3 over 2. Now, and we're going to use this for a lot of things, so I'm just going to have to get rid of this for the moment. Right, let us now decide what sine is. So sine of 60 equals opposite over hypotenuse, so that's root 3 over 2, and I'm going to say divided by 1, and I think divided by 1 is itself, so it's root 3 over 2. Sine of, so cos of 60 would be adjacent, which is half, divided by 1, which is half. So that goes in there. And tan of 60 is opposite over adjacent, so that's root 3 over 2 divided by half, which means times it by 2, so that's 2 root 3 over 2, which equals root 3. And that's that one. So we filled in all of that. Now we're going to re-mark up that triangle. So we're going to change what we know. So rather than using 60, we're going to use 30, which would be half of 60, which is there. And now, in order to do that, that's half, we are now going to use so that would be, this is opposite, this is adjacent, and that's still hypotenuse. So sine would equal, so sine of 30 equals half divided by 1, so opposite over hypotenuse, which is half. Cos of 30 would equal adjacent divide over hypotenuse, which is 1, which is root 3 over 2. You might be able to see what's happening here. And tan, I've just put that in the wrong place. Silly me. So that would be root 3 over 2. And tan 30 equals opposite over adjacent. So it would be root 3 over 2 divided by 1 over 2, which again is timesing, so that is, no, it's half divided by root 3 over 2. So it would be half times 2 over root 3, which is inconveniently 1 over root 3. So we'll times that through by root 3 over root 3, and we'll get root 3 over 3. So that is root 3 over 3. Okay, now, last thing we're going to do is we're going to redraw these triangles, and we're going to draw them as a isosceles right angle. So this is a right angle. This is 1, this is 1. And if those are both 1, that makes that 45, and that would also be 45, but I'm not going to mark that up. Okay, so that makes our hypotenuse 1 squared plus 1 squared equals 2. And, but that's root 2 because it equals c squared. So that equals 2, which is root 2. So c equals root 2. So I did not explain that very well. Okay, so using the 45, we are now going to do sine of 45, which would equal 1, which is opposite, hypotenuse adjacent. So it'd be 1 over root 2. Sine of, or cos of 45 would equal, again, adjacent over hypotenuse, which is 1 over root 2. And then what would tan be? So tan of 45 would equal opposite over adjacent, which is 1 over 1. This is 1. And that is how you find as many of those as you possibly can.